Hello, GraphQL Summit. How are you? My name is Marcin Gembala, and I'm here to tell you about building GraphQL servers in Python and Django using Python's most popular GraphQL framework, Graphene. So in this talk, you will hear about pros and cons of the stack that we are using, about my team's experiences from using this stack for over 3 years now, and a little bit about the general shape of GraphQL ecosystem in Python. So before we start, let me tell a few words about myself. So I'm Marcin, and I come from Wrocław in Poland, which is known as a city of 100 bridges. It's a beautiful place, and if you ever have a chance to come to Poland, make sure to put it on your list. Um, I work as a Python developer at a company called Mirumi Software. We are based in Wrocław in Poland, and we are basically a software house building web apps in Python and JavaScript. We are creators of Saylor, a GraphQL-first open-source e-commerce platform, which is one of the fastest-growing e-commerce platforms on the market currently. And for the last 2 years, I've been leading the development team behind that project. If you are interested in learning more about what I do and what my company does, you can follow me on Twitter. So to give you a bit more context about how we use GraphQL, I want to tell you more about Saylor, since this is the project that where our journey with GraphQL has started about 3 years ago. Um, so basically, as I said before, Saylor is an e-commerce platform, and you can think of it as a Shopify, but open source, or Magento, but actually fast. So Saylor consists of a few parts. First of all, we have this dashboard application that you can see on the slide right now. And this is the app where store owners can manage their shop. So it has a lot of management sections, starting from catalog management, orders, customers, and a lot of configuration options of your store. Basically, it's a large CRUD application. It's built in React and TypeScript, and it's entirely powered by a GraphQL API. Second, we have a public storefront for the customers. It's basically a template that you can take and customize to your needs. But out of the box, you get basic e-commerce features such as product listings, customer accounts, and checkout. It's also built in React and TypeScript, and it's powered by GraphQL API. It's a PWA application, so it works really well on mobile by default, and it supports offline mode as well. So at the core of this platform lies GraphQL API. And a few facts about this API. So we have currently about 50 queries and 200 mutations and about 500 types. We have authentication and features, authentication and permissions features based on JWT tokens. We also have service accounts and webhooks, which means that you can easily integrate third-party services that talk to your API, or you can receive updates in other services integrated with Saylor. Most of our top-level resolvers have filtering, sorting, and search capabilities. So all of that is open source. You can go to our GitHub page and find it there. If you want to host it yourself, then you just clone this repository and do it on your machine. If you are interested in a hosted solution, we are just about to launch a cloud for Saylor. If you want to play with the API or see our public storefront or the dashboard, there is a public demo that you can also check out. So what is important in this entire story is the fact that originally Saylor was a monolithic Django application. So it means that we had static HTML templates and all the views were built in the backend code. About 3 years ago, we decided to change our architecture and we started separating our front-end apps, rebuilding them in React and adding GraphQL layer on top of the Django-based backend. Mainly, there were two reasons for that move. We wanted to unlock possibilities of a single-page application, which means you are getting dynamic user interface, which usually results in much better user experience. We also wanted to unlock ability to integrate Saylor with other services by exposing GraphQL API as a single access layer to the platform. So since we've had a huge code base built in Python and Django, we picked Graphene to build our GraphQL layer. So Graphene is the most popular framework for GraphQL in Python. Actually, it was the only one when we started doing GraphQL in our project 3 years ago. It uses code-first approach, which means that you are building types and queries and mutations using Python classes. And schema is generated from Python code. Graphene has support for popular Python web frameworks such as Django, Flask, or Tornado, but you can also use it with pure Python. So this entire migration from Django-based architecture to a GraphQL-based one took us about a year. And now I want to share 4 lessons that we've learned during this time that you won't necessarily find in the documentation. So the lesson number 1 is that Django and Graphene let you rapidly build APIs. Let's see why. So first, I want to show you how we build models in Django to represent our business domain. This example shows a simple user model. As you can see, it's just a simple class where in a few lines of code and in a declarative manner, we are defining the fields available in this model. So when we started building our GraphQL layer, we had a lot of models like this. As you can imagine, most of them were much more complex. So we needed to represent these models as types in our schema. So how do you do that in Graphene? Basically, Graphene allows you to easily map your models to GraphQL types by creating simple classes, as this one on this example. So what's going on here? First of all, Django has this convention of meta classes where we can customize behavior of particular classes. So Graphene uses that pattern to let us define a model that this particular type should use as a reference. So in this line below, we say which fields should be mapped from our model to our Graphene type. This is very nice because by this, we don't have to necessarily map all of our fields to a type, which is not that what we always want. Like, we don't want to represent our entire database structure in GraphQL. Lastly, we need to add a query and actually use our type in the schema. We do that similarly by creating another class. So we have this query class. We have users field that returns list of all users. And we have one simple function called resolve users that simply uses Django ORM to get data from the database. As a result, we get this piece of GraphQL schema. So as you can see, Graphene translated this convention that Python uses of lowercase with underscores naming to camel case that GraphQL uses. And also field types are inferred from Django to GraphQL. Lastly, Graphene is able to generate default resolvers for those fields. So when we were mapping all of our functionality to GraphQL, we discovered that this code-first approach and ability to map models to types is very effective. And this let us progress very fast with building our API. Some fields can be easily mapped with default resolvers, but it's also fairly easy to build custom resolvers as using simple Python functions. And lastly, this declarative and class-based approach of Graphene is quite similar to what you do in Django. So this means that it's really easy to dive into Graphene if you're doing it for the first time. So we've seen how we build types. Let's see how to handle mutations. So it turns out that mutations are a bit more tricky and require more effort. So let's take a look at default mutation implementation in Graphene. So this is an example mutation which creates a product in our API. And a few things are going on here. So first of all, we have the input definition. So this is the data that comes to our mutation when user call this mutation. Then we have the definition of the output. So in our case, we want to return a new product. And lastly, we have the resolver. So this is a function called mutate that gets the incoming data from our input. And inside this function, we can execute our business logic and return a newly created product. So it's fairly simple, but in real life, there are a few problems with this implementation. So first of all, if you have a lot of mutation like this, you will quickly notice that there is no pattern for input data validation, which obviously you want to have in your API. Second, there is no unified errors handling. And lastly, if you have a lot of mutations like this one, like in our case, a lot of crude mutations for our dashboard application, you will end up with a lot of boilerplate code and a lot of duplications in your code. So how do we solve this issue if we have a lot of mutations to build in Graphene? To the rescue comes abstractions. So I want to show you a few abstractions that we've built that helped us a lot to build our API. So first of all, let's take a look at error handling. So we have this pattern which we called base mutation, and this is actually a base building block for all of our mutations. And it does a few things. So first of all, here we have definition of the errors field. It's a list field. It returns the list of error types, basically. So now every mutation that uses this particular mutation would get these fields as a default. So now we are, by using this base mutation class, we are getting the consistency in the shape of errors that we have in our mutations. And second, we have a custom resolver for our mutations. So yeah, we have this perform mutation function, which is our own resolver of that mutation, and in this function, we can put our business logic, and this mutation would be called inside the default one, so mutate. And we can only focus on performing the business logic inside perform mutation, while mutate does entire error handling for us. So this is really nice pattern that help us to create a unified error structure. Second, we have a lot of crude mutations in our API. So if you have a lot of such mutations to build, you will quickly notice that a lot of them follow the same pattern. So first of all, you want to clean your input data. Second, you want to create model instance from that data. Lastly, then you want to validate this instance. And lastly, you want to save all changes in the database. So to make things easier and to make it faster to build a lot of these mutations like this, we've built another abstractions that we've called model mutation. So let's take a look how it works. So again, we are using this meta class convention to tell Graphene which model it has to use. So in this case, we are using the product model, which means that this mutation by default will create instances of this model. And what it does underneath this model mutation is a few things. First of all, it can prepare the input data for us automatically, which means, for example, translating those base 64 IDs that GraphQL uses into database IDs in our system. It has a function to populate a model instance from incoming data, and it also has function to run model validation. So this nice pattern allowed us to quickly build a lot of similar mutations and reduce number of duplicated lines of code. So we've seen how we build types in Graphene and how we build mutations. So what about subscriptions? So it turns out that there is no native support for subscriptions if you are using Graphene with Django. The main reason for that is that Django is basically a synchronous framework, and it was designed for the request response pattern that were that was very common in the web of the past. But as you know, web is changing, and also the application and architecture is changing as well. So now we do use more service-oriented architecture, which means we have connections with different APIs, which means in turn that we need asynchronous calls, and that's not possible in Django. For example, also database access is synchronous in Django as well. It turns out that it is possible to support async requests with Django channels, which is kind of a wrapper around default Django application. But still, database access is synchronous, and if we want to access database using Django channels, we need to use decorators like database sync to async. So it is somehow possible, but it's not native, it's not built in Graphene, and you need to use third-party library for that, which also requires a lot of changes in your code base if you want to support that. So this brings us to the lesson number 4, which is additional libraries. So we realized that if you are building a fully fledged API, you need a lot of additional libraries in Graphene. So a few examples. First of all, JWT authentication and permissions. I said earlier that we have support for that, and this is true, but it's not available in Graphene by default. For that, you need additional library. Also, there is no native support for Apollo Federation, but there is some library that you can use, which enables that. Unfortunately, this is not very popular library, so sometimes it's very hard to rely on such libraries in production systems, because you will never know if they will be maintained anymore. There is also no file upload support by default, but there is one small project that adds that feature into Graphene. So these are just a few examples, but it turns out that some features are not implemented at all, and there are no libraries for that. So for example, query cost analysis is not available in Graphene at all. So to summarize it all, Graphene is a good framework, and it allowed us to successfully build a large API and end up with a really clean code base. But as you saw, it has some problems. So it's basically a little bit behind, for example, Apollo server. Uh, there are no subscription support, some features are missing, and also Django is synchronous. So you may be asking yourself a question, why do you actually use Python? If there are such problems with the stack, why do you actually use Graphene or Django? Why don't you just migrate to Apollo server? So these are really good questions that we've been asking ourselves a few times already. And yeah, the short answer for that is pretty simple. Basically, the answer is that we love Python. So we think that Python is a great language, and it brings a lot of benefits. First of all, it's very readable, and it helps you to maintain a really clean code base. Python also has a great community. And in the newest version, Python is already asynchronous. So this slide shows how the async await syntax looks like in Python. So it's pretty much like in JavaScript. As you can see, this piece of code is really readable, and yeah, that's how modern Python looks like. You can also observe that in the last developer surveys made by Stack Overflow or by GitHub, you can see that Python is gaining a lot of popularity in the recent years, being one of the most popular programming languages now. So our approach is that instead of leaving this Python ecosystem, we decided that instead we want to stick to it and focus on improving it because we see a huge potential in this language. So one of the things that we are doing for the GraphQL ecosystem is building our own GraphQL servers. So I want to show you Ariadne. This is a GraphQL server built entirely in Python. In modern Python, it's inspired by Apollo server. It supports asynchronous execution, so you can do subscriptions. You have a lot of features that are actually missing in Graphene. And a big plus of it is that it's maintained by a company and it's regularly maintained, as opposed to Graphene, which now has some problems with maintainers. So if you are interested in building GraphQL in Python, please check it out at ariadnegraphql.org. Uh, that's all that I've prepared for you. And if you have any questions about Saylor and GraphQL in Python, feel free to reach me on Twitter. Thank you very much.